Now I'm going to orient, or I'm not going to orient, but I'm going to choose the drawing plane to be consistent with what my last view was. I think I was in, at least I hope I was in the YZ plane. So that's what I'm choosing. So with the screenshot that I showed before, I believe X was pointing at us. So all that I'm saying is that I'm going to draw my port to be in this plane that you're seeing here, which is going to be in the Y and the Z direction. So that's where I'd like to start, is by drawing the gap port. So if you remember, to draw the port, we're going to use the same functions as before. So this little guy right here, the draw a rectangle, as soon as I click this, remember it's interactive. It's going to ask for information to drop locations, and the first thing it wants me to do is going to enter the rectangle position. So just like last time, I'm not going to worry about the actual locations. I'm just going to draw a rectangle in this view, and I'm going to come back and make an edit. So I haven't dropped any locations yet. So let's just make it so that it starts out in the negative Z and negative Y location. Any spot on this grid will do. And then now I'm going to choose the second point to be up here in the positive YZ area. Okay, and now that that's done, I have an object. I can see it's highlighted here. When I go into rectangle 1, I'm going to go into the create rectangle node, and here's where I can correct for these settings here. So what I'd like you to do is I'm going to highlight this whole position. Now remember, the format for typing a position in, it needs 3 numbers that are separated by commas. So if you look closely there, if your eyes are better than mine, you can see that there's a 0, comma, negative 0.03, comma, negative 0.015. So you only need 2 commas for the 3 numbers. So you have to make sure that we get it in that format. But what I'm going to do right now is I'm going to delete all of that. And I might surprise you, because I'm going to say my X is going to be 0. I'm going to give it a comma, and I'm going to make my Y dimension negative, and I'm not going to give it a number yet. I'm going to put a negative, and right after I type the negative sign, I'm going to create a name of a variable that does not exist yet. It exists on our PowerPoint slide though, so I'm going to type radius. I believe this is probably case sensitive. So I've got the X position with a comma, and now I've got the Y position not as a number, but as this negative radius. Now before I hit enter, I'm going to put another comma, and now I'm going to choose negative height, Height, and I'm using caps. So now watch what happens when I hit enter. So notice the name of this dialog box is called add variable. So the software has recognized that it doesn't know what this thing that I just typed in is, but because of where I put it in the form, it recognizes that this must be connected to a position. So it wants me to define that. So it's incredibly important that you see this view right now. Whatever variable name you chose is fine. So if you don't see a similar form in front of you right now, go ahead and pause this, and maybe rewind as needed to go back and make sure that you can get to this location. Whatever you need to do, because this is very important moving forward. We're in the process of setting up those variables and those parameters. So pause if you need to. Otherwise, I'm going to continue on with defining this. The name is good. It's shadowed out because I already gave it the name. The unit type, let's go ahead and hit the drop down and look at all these different things that we see here. And I know that what we are about to do is actually related to a position. So there's so many different things here. Acceleration, all these strange terms, angular jerk, angular momentum, all these different things that could possibly be related to our variable. But I know that what we're actually trying to do is going to be, even though it's a position, we're going to go ahead and give it a length. Okay, so the unit type, it's just the type. It's not the variable. So because I gave it that length, it knows that it's related to position or a distance or a length. So it knows that there are certain units that we would expect. Okay, so we're going to choose centimeters, and the value that I'm going to give it right now. So I would have to refer back to what we set up in the PowerPoint. If you remember, the radius was a value of 0.225. And since it's centimeters, I'm just going to click OK. So now I'm going to go to the next variable, which is our height. And that unit type also has to be set. So I'm going to go look up length again. And we're going to change millimeters to centimeters. And if you remember, our height happened to be the same number as the radius, but I'm going to type in it as a separate variable. So 0.225. And we're going to say OK. And now that we have these variables defined and they have the proper numbers assigned to them, I know that the size, remember that we just defined the position in terms of two variables. Now the size is actually going to be a length in each direction. So the y size we know is going to be the radius times 2. So be careful how you type it. I'm going to do exactly the way I define my variables, capital R, everything else is lowercase, R-A-D-I-U-S, and I'm going to use the asterisk. So I'm going to hold the shift and find number 8 on my keyboard, which is the asterisk, and I'm going to, that's multiplication, that's times 2. So that's an expression. So I've got a variable now with an expression. It's being multiplied by 2. We did this in the earlier setup. When I hit enter there, it's going to advance me to the next, to the z size, and the z size, I know that's going to be the height dimension, right? So there's no expression here, so I'm just going to say capital H-E-I-G-H-T, and that's my height. And as soon as I hit enter there, you should see something very similar to what I'm showing here. So I want you to make sure that you verify that you've got the same look and feel that I'm showing here, right? So your position is written in terms of these two variables with negative signs in this case. The axis is going to be the same, and your y size and z size. So if you don't see a similarity there and the view is not the same, then take some time to make sure that you actually get this, because we're about to make one small adjustment before we go to build in the cylinders. Okay, so hopefully by now you're seeing the same thing. And what I've already noticed is that if we compare this to our earlier design, one thing that we notice is that this is not centered. So our port, because of the choice that I made for where its z position is going to be, negative height, as a position, it looks like the height is actually correct, but the position of it is not centered in the x-axis. So watch what I do here. I can now make my position an expression. The variable already exists. It says negative height. So if I just divide it, if I only go half the distance down, divide it by 2 and enter, it should shift up. And see if that makes sense to you. All I did was just change the position by using a variable and an expression to be able to get that in the right location. It's still going out the same height, but it started at a different z position. So my height itself did not change. It's just the location in terms of that variable. So I'm going to give you a minute to make sure that you see this same view. So pause the video if needed, and then we'll get started on adding the cylinders. Let's move on. We're going to change the plane from the YZ, just like before. We created the cylinders in the XY plane. So that's a perpendicular plane to the one that we were just in. So what that means now is that when we create the cylinders, we know that the circle is going to be defined in the XY plane, and then the height is going to be referencing the Z dimension. Okay, so let's just go ahead and do that, but we're going to do it the same way. We're going to create an additional variable. We already have the variable radius, which you've probably figured out is going to be important to us, but we're also going to use that variable height that we talked about. So create the cylinder just like last time, but now when we draw the cylinder, I'm going to do what I did before, but I want to intentionally violate that condition of trying to keep it within the same to keep it the same size as that gap port, and I'm just going to make up a size here. We know that that's not right, and we're about to go in and correct it. So when we do, we better see that the cylinder radius is snapping, or I shouldn't say snapping. We're going to do it differently, but it should coincide with the width of that rectangle. And then, of course, the height is going to be a lot taller than that. So let's do the same thing that we did with the sheet when we created it. I'll click on the Create Cylinder node, and let's go ahead and make the position. What's the appropriate position for this? We're going to go ahead and say we know that we want the X location to be actually centered. This is the cylinder. And starting it at 0 is actually the appropriate location for this. So I'm going to back over these two. Remember to keep the commas in line. I'm just going to wipe out everything so I can start from scratch here. So I'm going to use 0. I'm going to say comma. And now what is the Y position? Well, the Y position is also going to be at 0. So I've got 0, comma 0. And now I'm going to put another comma in. And my Z position is going to be, it's going to be offset from the origin. If you remember, it's going to be offset half of the gap port height. So if I go the full gap port height, it's going to be too high, just like when we originally mis-centered that gap port. So what I'm going to say is height, HEIGHT, and I'm going to divide it by 2. Okay, and when we do that, we should see that, sure enough, let me go ahead and orient it this way. You can see that there's no overlap. So it's at, if it's supposed to start at the very edge of the gap port, it appears that we place it in the right location. Okay, so so far so good. So again, that's just the center position. The axis is in the z-axis. That's right. We want it to go along the z-axis. Now for the radius, we already have a radius defined. So watch what happens when I replace the value that I arbitrarily chose on the screen from 0.3, and I'll use the value of radius. And look at that. I didn't have to snap it to the edge because this was all analytically set up, or I should say parametrically set up. Okay, so that looks good. My radius looks good. Let's fix the height. And if you remember, let's see. So the height here is we chose that to be 0.4 by picking off the screen. Now we're going to type in a new variable because we have not defined height yet. So when I type in the word height for height, oh sorry, I meant to say length. We're going to type in a new variable for length. Okay, so make sure your height says length instead, and then we get the same dialog that pops up. Unit type is actually going to be, was it distance or length? So here's length, and instead of millimeters, we're going to keep it in these units, and then we're going to go ahead and call it length. Actually, no, we're going to give it a value of what did we define? 6.745. So now the value, again, I'm choosing the number that I started this whole conversation with, of 6.745 centimeters. It's everything else. If you have the same settings, you should see that we have one of our legs. What we're going to do next is replicate this in a different way. We haven't done this before. I'm going to use these move and rotate along lines and axes commands. So watch what happens here. First of all, make sure that you actually see the same view. So take as long as you need, pause the video to get caught up. But I'm going to select this cylinder now, and I'm going to go to move. So not this rotate command, but the one to the next, right next to it. And it basically says duplicate around the axis. So what would happen if I rotated this cylinder 1 around the x-axis 180 degrees? You might take a guess at what would happen if I simply fixed along this coordinate. Imagine if I just rotated it so that the y-axis was going into the z-axis, but I continue on further, more than 90 degrees. I go all the way to 180 degrees. If you can think that through, you can see that it would end up being flipped in position in the negative z. So what this command is going to allow me to do is rotate it, but I can keep the original. So I just hit the button with it being selected. And let's fill this out together. I don't want the axis to be the z-axis. I want it to be, it could either be the x or the y, and we can talk about that later. But I just want to get a value in here. I'm going to choose the x-axis. I'm going to choose 180 degrees. We can keep it in degrees if you prefer radians. You can give that a shot and do it with radians instead. But I'm going to do 180 degrees, and I want the total number to be 2. So what that means is that the original is going to stay where it is, and then a copy is going to be produced, and you can see the shadow. So this little segment here with the circle up here and the circle, those are indicating the endpoints of the new cylinder that's about to be created. Okay, so I want you to use these exact same settings, and so pause if needed to get caught up to this point because I'm about to hit OK. And when I do, you should see I have 2 cylinders now. So instead of calling it cylinder 2, it called it cylinder 1_1, and that's fine. So we're just going to leave it at that. And this starts to look pretty much identical to that design that we had in HFSS Design 1. So take as long as you need to get to this point because we're about to set the material properties and hit simulate and compare the results. So if you remember, we had to assign on Tuesday when we did this, we had to assign this a metal property, and we use perfect electric conductor. So right now the cylinders are defined as vacuum. I'm going to choose each of them. I click on the first one. If I hold Control down and click the second cylinder, it tells me in the bottom left that 2 objects are selected. I don't want the port to be selected because that's going to be a different operation. So with this, if you remember, we do a right click and I can choose Assign Material, and we'll let that load for a second depending on the database libraries that we have connected. Sometimes it's instant, sometimes it takes a little longer. But when this material window comes up, I'm going to type in PEC for peak. Okay, and I'm just going to hit OK. And that's okay. It's just talking about redundant libraries. So if yours was successful, you should see it no longer says vacuum. The 2 cylinders are underneath the node called peak. And that's all we needed to do for that. The next operation was going to be to set the port. So pause if you don't have your cylinders defined as perfect electric conductor, because now we have to set the port, and you have to do that first. Okay, so let's choose the rectangle 1. With that selected, I'm going to right click and I'm going to assign excitation. If you remember, we did a port and we actually chose the lumped port. So when I bring that up, I'm going to leave the names all defaulted here, and I'm going to choose the reference for the terminal to be the second conductor. It's not going to make a difference. And when I do that, you should see now I have in this design, I have excitation set, and I see my port. If I choose my port, and then I can see my terminal reference. We don't need to worry about what all that means at the moment. I just want you to make sure that you have the same setup. And if you do, when we hit simulation and validate, we should get everything clear. And I'm going to give you a second before I hit the simulate button because I want you to get caught up. So take as long as you need and unpause when ready. So if you were able to get a clear validation like I did, then I'm going to go ahead and hit Analyze All. So just like before, we should expect this result to go through pretty quickly. After all, it is the same device, so the only reason it wouldn't would be maybe if we made some mistakes or maybe left something out. So I'm going to pause while this continues to solve, and we should be right back here pretty soon. So if you followed along with everything the way that I did it, you'll notice that the results node, these items, the gain plot and then the terminal S parameter plot, both of these are different types of results that we set up before. They now have color back to them, meaning that They're no longer stale results. They've actually been updated. So if I double click the gain plot, there's no surprise that I'm seeing the exact same thing that I saw before. So there's my donut pattern, for the gain, and then for my S parameters, I can see that this is also very similar. So maybe there's a slight change depending on changes that maybe we inadvertently made, but for the most part, you're going to see that big dip near 1 gigahertz, just like you're seeing here. So this was a success, and it may seem like a lot of work for what we did. All we did was basically reproduce the exact same antenna in a different way, right? So if I go back to that original design and I expand that out, all these things basically look the same. There's my donut pattern for the first design, and there's my S parameters for this design. So what was the point in doing all of that? Well, that's the topic of the next session. So now that we have a properly parametrically defined antenna, in the final session, if you remember, we started this whole series by marching through these 3 different objectives. We just completed the rebuild of the antenna parametrically, and we verified that it's identical to the first version. And now we're going to set up, the next thing that we're going to do is set up this parametric analysis. So we'll probably do that after the Thanksgiving break, and we'll continue on with discussions about the value of parametric analysis. And when you start seeing how we can play around with these different values, it'll be very apparent to you what the value of the parametric analysis is. And we're going to be using for lots of other models moving forward. So enjoy the break, and we'll see you after. Take care.